Step outside on a clear day, and you feel its warmth, a comforting embrace that sustains all life on Earth. It's a feeling we often take for granted, a constant presence in our lives. This warmth emanates from the sun, the heart of our solar system, the source of nearly all energy on our planet. A vast, churning ball of hot gas, a nuclear furnace burning with unimaginable power. It's a dynamic and ever-changing entity. Indeed, it's nearly 100 times the diameter of Earth, a truly colossal presence in our cosmic neighborhood. For billions of years, it's been our constant companion, dictating seasons, driving weather patterns across the globe, and fueling the intricate web of life that thrives on our planet. Without it, Earth would be a frozen, lifeless rock adrift in darkness, a barren wasteland devoid of warmth and energy. The sun's immense gravity holds us in a stable, predictable orbit, allowing life to flourish in a relatively constant environment. We are, in every sense, children of the sun, utterly dependent on its energy and gravitational pull for our very existence. But what if our anchor changed? What if the familiar warmth and light were replaced by something different, something unknown? What if we swapped the sun for something else, a different type of star, or even a more exotic cosmic object? This thought experiment reveals just how unique and precious our star truly is, and how fortunate we are to have it as our celestial guardian. By imagining alternatives, we can appreciate the extraordinary circumstances and the delicate balance of factors that make life possible on our planet. Let's explore what would happen if other stars, or stranger objects like black holes or neutron stars, took the sun's place in our solar system. How would our sky transform? How would the oceans react? And how would our very existence be altered by such a dramatic change? Through this journey of hypothetical scenarios, we'll gain a deeper understanding of the delicate balance that governs our world and makes it habitable. This is the story of gravity, light and heat, the fundamental forces that shape our home and dictate the conditions for life as we know it. Imagine replacing our sun with a red dwarf, the most common star in the galaxy. The world would be cast in a dim, coppery twilight like a sunset that never ends. The blue sky would vanish, replaced by darkness and a faint red glow. Red dwarfs emit far less energy. Earth would plunge into a deep freeze. Oceans would freeze solid and most life would perish. With less mass, a red dwarf's gravity would weaken, causing Earth to drift outward, worsening the cold. Our year would lengthen and the rhythm of life would be lost. Photosynthesis would falter under the weak red light. Only some microbes deep beneath the ice might survive. The surface would become a silent, frozen wasteland. Our vibrant world would be locked in a permanent winter. A red dwarf's gentle glow would be beautiful but deadly. Life as we know it would not endure. Now picture a white dwarf, the dense hot core left after a sun-like star dies. In the sky, it would appear as a single piercing point of blue-white light. Its initial radiation would strip away our atmosphere and sterilize the surface. After that deadly flash, Earth would freeze, receiving almost no warmth. Our orbit would remain mostly stable, but the world would be locked in darkness and cold. Days would be marked by sharp, stark shadows, no soft sunlight, only harsh contrast. Over billions of years, the white dwarf would cool and fade, becoming a black dwarf. Earth would circle this stellar ghost, frozen and lifeless. The sky would be empty, save for a fading ember. Our planet would become a monument to a star that once was. No life could survive this transformation, only silence would remain. Now imagine a neutron star, an object with the sun's mass, crushed into a city-sized sphere. Its gravity would be so intense it would tear Earth apart in moments. Tidal forces would stretch and shatter the planet, triggering global earthquakes and eruptions. Earth would be ripped into a stream of debris, spiraling into the neutron star. Even if the planet somehow survived, the radiation would be lethal. Neutron stars have magnetic fields billions of times stronger than Earth's, unleashing deadly beams of energy. Our atmosphere would vanish instantly, and the surface would be bombarded by high-energy particles. The sky would glow with a disk of superheated plasma, Earth's remains. The end would be violent and fiery, not a slow freeze. No life could withstand this cosmic destruction. The Earth would be obliterated, leaving only a brief, brilliant flash. A world consumed by the crushing heart of a dead star. What if our Sun became a black hole of the same mass? Surprisingly, Earth's orbit would remain unchanged. Gravity depends on mass, not size. But the Sun's light and warmth would vanish, replaced by a patch of perfect darkness. The only sign of the black hole would be the way it warps the stars behind it. Earth would quickly freeze, the oceans turning to ice. Life on the surface would end in darkness and cold. Photosynthesis would stop, and food chains would collapse. Only deep-sea organisms near geothermal vents might survive, oblivious to the world above. The cycle of day and night would end, replaced by eternal night. Earth would become a frozen tomb, orbiting a point of infinite darkness. The Sun's absence would turn our world into a silent, icy relic. In the void, only a faint spark of life might persist deep below. Now imagine our Sun replaced by a blue giant. Massive, hot and blindingly bright, the sky would be dominated by a colossal blue-white orb, flooding Earth with searing heat. Temperatures would soar, boiling the oceans and turning the atmosphere to steam. A runaway greenhouse effect would make the surface hot enough to melt rock. All life would be incinerated, Earth would become a scorched, molten cinder, the giant star's gravity would pull us closer, shortening our year and intensifying the heat. Blue giants live fast and die young, ending in a supernova that would vaporize the planet. No form of life could survive such extremes. The elements of our world would be stripped away and cooked into plasma. Life exists only within a narrow band of possibilities. Too little heat, and the world freezes. Too much, and it burns. Our Sun sits in the Goldilocks zone. Not too hot, not too cold. The right kind of star is everything. Let's consider a mind-bending scenario. What if we swapped the Sun, our life-giving star, for Jupiter, the largest planet in our solar system? It's a cosmic game of musical chairs with potentially devastating consequences. Jupiter emits no light of its own. It's a gas giant reflecting the Sun's rays. With the Sun gone, replaced by a non-luminous Jupiter, darkness would fall across the entire solar system. A perpetual night would descend upon all the planets. Jupiter's faint internal heat is negligible, a mere whisper compared to the Sun's roar. Earth would rapidly freeze solid, becoming a desolate, icy wasteland. Jupiter's mass, while substantial, is only a fraction of the Sun's immense gravitational power. It's a David and Goliath situation, but with gravity. So the solar system's gravitational anchor, the force that keeps everything in its place, would vanish or at least weaken considerably. Earth and the other planets, no longer held in their familiar orbits, would drift into space, becoming cosmic wanderers, lost in the interstellar gulf. Our world would be lost, untethered from the Sun's embrace and frozen solid, journeying through the cold void, a lonely sentinel in the cosmic ocean. Life would have no chance to survive in such conditions. The deep freeze and isolation would be final, extinguishing any spark of existence. The sky would be filled with the distant faint light of the Milky Way, a beautiful but ultimately meaningless spectacle seen by no one on a frozen, lifeless Earth. The Sun is not just our source of light and heat, providing the energy that drives our planet's ecosystems. It's our gravitational master, the anchor that keeps us safely in orbit and prevents us from spiraling into the unknown. Without it, the delicate harmony of the planets, the intricate dance of gravity, would collapse into chaos. For life to exist, we need the right kind of star, a stable and reliable source of energy, and one massive enough to hold its family of planets close. The Sun's role is irreplaceable. It's the foundation upon which our existence is built. We've imagined our world under alien suns, some scorching, some dim, some absent altogether. We've pondered the consequences of a cosmic shift, a change in our stellar neighbor. Each scenario, however fantastical, ends in extinction or a drastically altered existence, revealing just how precious and how perfectly suited our Sun truly is for life as we know it. It's a delicate balance, a cosmic dance of energy and distance. Our star is a yellow dwarf, not too big, not too small, just the right size, temperature and luminosity to foster life on a planet like ours. It's a Goldilocks star, if you will. It provides a steady stream of energy, bathing our planet in warmth and light, perfect for the delicate processes of life and the essential miracle of photosynthesis. Its substantial mass keeps Earth in a stable, nearly circular orbit, preventing wild temperature swings that would render our planet uninhabitable. No elliptical extremes here, just a gentle, life-sustaining path. The Sun is remarkably stable and incredibly long-lived, shining with a consistent intensity for billions of years, a testament to its robust nature. This incredible longevity has given life the vast stretches of time it needs to evolve, diversify and flourish into the complex ecosystems we see today. It's a story written in starlight and time. Our Sun is a patient, dependable guardian, a constant presence in the cosmic ballet, watching over our world with unwavering dedication. Next time you feel its warmth on your skin or witness the breathtaking beauty of a sunset, remember the profound connection we share with our star. We live in the gentle grace of a very special star. In a universe often characterized by extremes, by violent events and unpredictable forces, our Sun stands as a beacon of stability, a constant source of light and warmth. It anchors our world in its orbit, powers the intricate dance of our climate, and ultimately fuels every living cell on our planet, from the smallest microbe to the largest whale. Our very existence is a testament to being in the right place at the right time, orbiting the right star, a confluence of cosmic circumstances that has allowed life to not only emerge but to thrive. And that, perhaps, is the most wonderful and humbling fact of all, a reminder of our place in the grand tapestry of the cosmos.